So my name is James Ong, and I'm presenting lining up the inflammasome in influenza. I recently watched a 90s movie, and it went like this. The main characters must catch a mouse, living in $1 million mansion they're trying to sell. This mouse is cunning, avoiding the characters' traps. The characters become so desperate and paranoid in catching the mouse that they end up destroying the mansion. Hands up to those who've watched this movie called Mouse Hunt. Oh, okay, some people. It's a great movie to watch, and I highly recommend watching it with your friends and your family. Getting influenza, however, is not what I recommend. Influenza is a viral infection of the lungs, where one is bedridden with fever, coughing, and aching muscles. At worst, one could land in hospital and die with a destroyed lung. Influenza also threatens societies. At the moment, influenza viruses from birds are killing half the people infected. Should these viruses mutate to spread between humans, we could witness an influenza pandemic that devastates our aging population. And, like our mouse in the movie, this influenza virus is cunning. It mutates to avoid the traps set by drugs and the immune system, allowing it to grow in peace. Influenza also drives the immune system against itself by hijacking a protein called the inflammasome. This protein is normally activated during an infection, where it sets off an alarm to attract immune cells to the lung to destroy the virus. However, influenza viruses from birds can kick the inflammasome into overdrive. The immune system overreacts to produce a firestorm that destroys the lungs. So the question is, how does the inflammasome overreact during influenza? Thankfully, mice can be used to answer this question. In my PhD project, I'm working with a mouse where a molecule attached to the inflammasome lights up the whole protein. We can use these mice to determine when and where the inflammasome is activated, even if the mouse glows. Anyways, the exciting thing is that I found some inflammasomes in the airways of the mice. This is an important finding, as the airways are constantly exposed to microbes in the air. This activates the inflammasome and the immune system to destroy the virus and possibly the lung. With these results, I will next infect these mice with influenza and track where in the lung the inflammasome is overactive to cause disease. The results of my PhD project will shed a light on how influenza redirects the inflammasome against its own immune system. We can use these results to discover new drugs to calm this panicking along, giving the immune system time to catch and destroy the virus. And that could be the difference between a lung that is healthy and a lung that is destroyed in an influenza pandemic. Thank you.